Hello everyone, welcome to the presentation. My name is Prakash Chipa. Today I am excited to talk about the work Open Vocabulary Object Detectors Robustness Challenges under Distribution Shift. This work is accepted in ECCV Workshop 2024. This work talks about the robustness challenges for recently developed Open Vocabulary Object Detection Foundation models. So the video language model based object detection has allowed us to go beyond the object detections, beyond the fixed categories, and allow us to zero shot learning. However, there is a limited focus on the robustness aspect of these open vocabulary object detectors models. So this study is all about to identify the limitations of such object detection models by evaluating them on comprehensively on different out of distribution benchmarks. So we have considered multiple benchmarks which exposes the model to different kind of a distribution shift. One of the benchmark is COCO-O, which has a six subsets of object detection categories based on, and it causes the distribution shift based on the decreasing detail of the object details, textures, and color shape, as you could see in the examples also. And the second benchmark is COCO-DC. This particular benchmark is focused on object to background compositional changes. So in the images, you can see the background is changed to different color, texture, adversarial aspects, and based on the captions. Then the third benchmark is COCO-C, which is derived from original COCO, where the corruption is being introduced to the original images by by taking the algorithms. So such corruptions like blur, noise, and so there are total 15 categories. So now coming to the vocabulary, open vocabulary object detectors. So we have considered three recent models. First is Grounding DINO. So Grounding DINO is a language guided detection model which uses grounded pre-training with the human text input, and it leverages the cross modality transformer where the image and vision and language open set detection is being used. And the second model we consider is YOLO World, which uses contrastive pre-training between visual and text, and it also combine the transformers with the CNNs for the large scale pre-training and for better accuracy detection, like better detection with the greater accuracy. Then we come to the another model is OWL-ViT. So this model is VIT based. It has adapted for the object detection based on VIT transformers, and it uses text driven classifications. And in order to evaluate these foundation object detector models on out of distribution benchmarks, we have designed one zero shot evaluations where the image and their labels are fed separately to the object detector models, and we focus on detection prediction capability of these models. Now, with this detailed investigations, we have summarized some of the results here. So on the left side, you could see when these models are exposed to benchmarks like COCO-O and COCO-C, which has a distribution shift due to the corruptions and the natural object and image level details decreasing aspects. So all the models have shown significant performance decrease when they are exposed to such models. And similarly for the COCO-DC also, we could see that all the three models have seen performance decrease. However, for COCO-DC, Grounding DINO seems to be more robustness than others. And if we look at the more detailed analysis on the results part, so in the throughout, like one of the aspect that in the COCO-C we have several severity levels up to 5, And the comparative study found that grounding DINO seems to have a performance decrease like any other model, but still it sustains than any other model on the robustness part. Similarly, we can see that if when we look at the corruptions based on the different groupings like blur, weather, and noise and digital group. So the general pattern is that model are able to, some of the models like, in specifically the grounding DINO is able to sustain the performance. However, the other models has shown performance decreases. But in general, all three models we could see when they are exposed to the distribution shift due to any meaning of distribution shifts like the corruptions, the natural reasonings, or the background, when they are exposed to such adversarial examples and environments, they tends to perform poorly than the standard distribution capabilities. So, and here also you could see one of the visual example on the COCO-O where all three models are exposed, and when the information is getting decreased from weather painting to the cartoon and tattoo, then the sketch, the model zero shot capability is also seems to be decreasing. So the final remarks on this, that although this VLM-based OVODs models are enabling zero-shot object detections on the real-world applications, however, it is very much important to understand that the robustness of this model has to be studied well and to work on it in order to make those models future ready for real computer vision applications. With that, I thank you everyone.